Good afternoon. Say hello. Welcome to the second day of the Huawei Analyst Summit 2020, the 17th consecutive event, the first time we've had to do it mostly online. I hope all of you had a chance to listen to the keynotes yesterday, and today we're moving into more detail. Over the last several years, there's been a lot of talk in the media, in the industry about wireless 5G. And maybe it's easy sometimes to forget that there's this other technology called fixed line, which is kind of important. So that's the subject and the topic of today. We all rely on fixed line telecoms, fixed line technology, and Huawei and the industry has been moving things forward in that space too. We're going to talk about that today, and we're going to talk about something called F5G. Fixed 5G, future of fixed line networks, the fifth generation of fixed line technology. When we look at wireless, we've seen a move increasingly over time to a single global standard. That's efficient, beneficial for everybody. Today we're going to talk a little bit about the same principles in the fixed line technology world. We have a number of speakers online, but we're going to start with our first speaker here in the room. Please join me in welcoming to the stage Executive Director of the Board, David Wong.
Good afternoon, everyone. First, let me welcome you to the F5G press conference on behalf of Huawei. Like the host said, F5G stands for fixed 5G. We know that in the mobile world there is 5G, and here we put the letter F before 5G. It means the fifth generation of technologies for fixed network. This year is special. Over the last few months, in China, the outbreak of COVID-19 changed the way people work and live significantly. In Q1, we've seen a lot of people working from home, learning from home, and that has become a new lifestyle of people. In China, more than 18 million enterprises have staff members working from home, and our company is no exception. We resumed work on the 3rd of February. 60% of our staff members worked online, coded online, compiled the software version online, and a lot of people, that is 230 million learners, took online courses. And online medical consultation has become a new trend. As I read from the news, there is 12 million online medical consultation every day. So homes are no longer only the center of personal life. It is at the same time the school, a hospital, and an office. So home network is very important to our life and our work. On the carrier side, a number of leading carriers in the world take the development of mobile 5G and fixed 5G as their priority, and they recognize that the collaboration between the two is very important, and there is more value discovered from broadband and a private line. and the infrastructure is being made closer to the users. At the same time, we need to recognize the value of broadband network to the society and economy. According to the World Bank, the broadband penetration up by 10% will contribute to the 1.38 percentage point growth of GDP. And in 2019, the Economy and Employment White Paper in China pointed out that the 180 million kilometers of fiber supported the digital economy in China, which is worth 31.3 trillion yuan. We can see that the broadband network and relevant technologies have become a driver of economy. But over a long time, people have been only aware of the importance of mobile technology. But actually, both mobile and fixed technologies can be dated back to the 80s, and wireless and fixed technologies have been there for 40 years now. And there is ITU, which makes the spectrum policy and develops the technical framework. And the 3GPP is an organization that defines the step change in different generations of technology. GSMA is an industry association that promotes a unified industry ecosystem around the world. So for the wireless industry, there are these industry organizations that contribute to the prosperity of mobile. And Mr. Guo Ping said yesterday, you know, in the first generation of mobile, in an analog era, there were 8 standards, and now for 5G, there is a unified standard called New Radio. As the standards are unified, there is interoperability, and it gets rid of the fragmentation, and it gives you economy of scale. And this is the foundation of the prosperity of mobile industry. However, for the fixed world, there's still a lot more we can improve. To start with, there is no unified standards. There is ITU, ETSI, ITF, and BBF, OAF, all these groups, and that is not a complete set. So in a fixed world, there are a plethora of organizations making their own standards, so it's hard to coordinate everybody. And also the direction and the timeline of standards from this organization are different. Another thing is there is no step change between a generation of fixed technologies. Take home broadband as an example. 10 years ago, around 10 years ago, there was GPON. Before that, it was copper. Now we have 10G PON. But as the technologies evolve, there is no clear or distinct step change between the generations, and there is no clear path of evolution from older technology to newer technology. That's why in a fixed world, there lacks the clarity. There is no driver to unify the global ecosystem and promote the maturing of the ecosystem and promote the adoption of the technology in the society. In a fixed world, there is no organization like GSMA that coordinates or facilitate the ecosystem. So the ecosystem is less mature, and there's still the interoperability challenge. That's why we want to promote F5G. In February 2020, ETSI put forward the F5G proposal. The vision of F5G is fiber to everywhere. First of all, fiber can be deployed to the home, to the room, to the desktop, to the building, every office, every desk in the office. Fiber can be deployed to base stations, data centers. So fiber can be deployed everywhere. Globally, the more developed countries have more frequently than not done a better job in fiber deployment. Countries like China stepped up the effort in fiber development. So we've seen a big development on this area, but still there is a gap from the vision of fiber to everywhere. So this vision of fiber to everywhere has three main pillars. The first one is FFC. And on the bottom right corner, you can see it means full fiber connection. We hope that fiber can be extended to wherever traffic is generated. The second pillar is EFBB, Enhanced Fixed Broadband. With EFBB, homes can use 10 GPON. The average speed can be gigabit per second. We call these homes gigabit homes. And we can also have gigabit buildings or even 10 gigabit buildings and terabit campuses. And for the backbone, in countries like China, our provincial backbone can achieve 400 gigabit per second. Our provincial backbone is at a similar level of the national backbone in Europe, and this backbone can have the speed up to 800 gigabit per second. And guaranteed reliable experience is the third pillar. And the QoS packet loss rate is improved a lot, and the latency is very low, and the 5.9 reliability is another feature. So I've shared with you the three pillars: FFC, full fiber connection; EFBB, enhanced fixed broadband; GRE, guaranteed reliable experience. To support the F5G strategy, we released the full optical network solution. We want to build the optical network to everywhere. 5G is a household name nowadays, and it enables everything to be connected. F5G supports homes, data centers, and offices to have access to bigger capacity. Only when there is coordinated growth and development of 5G and F5G, we can enter the age of smart world, intelligent world. 5G is already familiar to people, but F5G would need more attention, and that is something we worked on in the last few years with our partners. We worked to promote the vision of F5G, and we are working to build the F5G standards and ecosystem. Let us join hands to promote the development and growth of F5G and to promote the joint and collaborative growth of 5G and F5G. And the vision of F5G is fiber to everywhere. Thank you.
Thank you, David. It seems I was in too big a hurry to hear what David had to say because I was supposed to play a video. So now I'd like to play the video, and after the video, we'll go on to the next speaker. You roll the video, please.
Lying above us is the starry galaxy. Myths, astrology, science fictions, the universe. Inspiring each generation to explore the unknowns. Down on Earth is the digital galaxy. Voice, web, video, and UHD, from daily communications to audio-visual interactions, inspiring each generation to explore all possibilities on connectivity. We call this galaxy the fixed network. Now, relying on breakthroughs in new technologies, we are eroding in the fifth generation fixed network era, F5G, which will invigorate all industries with gigabit energy. F5G delivers ultra-high bandwidth, enabling the gigabit connections to traverse oceans and continents. Serving every home and organization, it breaks down the boundary between virtuality and reality, removing all barriers of time, space, and technology, enriching the ecosystems of industries. F5G delivers an ultimate experience. It monetizes every millisecond, whether in manufacturing or finance. Works more wonders in life through remote medical cooperation and realizes greater possibilities as cities become more intelligent. F5G achieves full fiber connectivity, breaking the chains of distance to extend the fibers to every desktop, room, machine, and everything else. It accommodates 100-fold more connections and increases the market potential by hundreds of billions of dollars, advancing the digital economy and creating infinite possibilities. F5G is opening new doors, transforming what was incredible yesterday into what is normal today. F5G will continue to grow, extending to optical switching, all optical network, and beyond. F5G will collaborate with 5G to create a fine new ecosystem, welcoming all industry partners to build an intelligent world.
Now, I was just thinking as that video was playing, before Huawei, I used to work for a telco. And I remember a discussion about how could we ever deliver more than 2 megabits to customers. And I'm young, so it's not that long ago. Right? The pace of innovation. Time for the second speaker. We're going to move on to video from Beijing. Please welcome to the event virtually Pengwei, who's the chairman of the Technology Steering Committee for China Telecom. Please, on video. Thank you.
Hello, good afternoon. My name is Pengwei. I'm the chairman of Technology Steering Committee, China Telecom and Corporation. Today, I'd like to share some thinking on the fiber 5G. First, I'd like to share my thought about the necessities on defining the fiber 5G. To support a series of new technologies and new applications, such as 5G, and push fiber to everywhere, telecom industry have to define a new generation fiber network, fiber 5G, with a unified definition, architecture, function, capacity, and performance in order to reduce fragmentary private specifications and gain the benefits of a scale economy like a cellular system. In my thought, transport, access, and customer premises networks are three major areas to be defined as part of fiber 5G, and the priority is the first two. First, I'd like to share my thinking about the generations on fiber transport. To me, for the new generation on the fiber transport means new spectrum and new systems. One generation every 10 years, 10 times more speed, 10 times less bit cost. For the first generation, it was happened in 1980s. It was analog and short-reach data system. For example, Gigabit Ethernet, fiber channel, FTTH. It was a multimode system. Working wavelength is 850 nanometer. No world standards. For the second generation, it was happened in 1990s. It was a PTTH system, pre-synchronized digital hierarchy. It was asynchronous TDM. Typical code is 5B, 6B, 1B, 1H. The modulation format is OOK and NRZ. Typical speed is 2 meg to the 140 meg. It was a single mode system. Working wavelength is 1310 nanometer. No world standards. Third generation, it was happened 2000s. Based on SDH, there was a synchronized TDM system. Typical modulation is OOK, NRZ, and RZ. Typical speed is 150 meg to the 10 gig. It was a single mode system. Working wavelength is 1550 nanometer. It was a world standard. For the fourth generation, it was happened 2010s. It is based on OTN and WDM. Modulation format is OOK, PDM. Typical wavelength number is 80 wavelengths. Typical speed is 1 gig to the 100 gig. It was a single mode system. Working wavelength is 1550 nanometer. That was world standards. For the fifth generation, it is going to happen 2010s. Typical system is LODEM and OXC. It was all optical system. Modulation format is OOK and PDM. Typical wavelength number is 80 wavelengths to the 120 wavelengths. It was also the single mode system. Working wavelength is 50 nanometer plus. The standards is to be defined. Next, I'd like to share my thinking about the generations on fiber access. For me, new generations means new spectrum and system. One generation every 10 years, 5 to 10 times more speed, 5 to 10 times less bit cost. For the first generation, it was happened in 1980s. System is the DLC, which is the representative is a digital loop carrier. It was invented by the Berco. It was the first typical point-to-point system, which can support hundreds of phone lines, no world standards. For the second generation, it was happening in 1990s. It was TPON, which is invented by the British Telecom. It was the first point-to-multipoint system. Modulation format is OOK and NRZ. Typical speed is 20.48 meg, but no world standards. For the third generation, it was happening 2000. There was ATM PON and broadband PON, which is based ATM. It also the point-to-multipoint system. Modulation format is OOK, NRZ. Typical speed is the 622 meg and 1 gig, no world standard. For the fourth generation, it was happened 2010. It was EPON and GPON, point-to-multipoint system. Modulation format is OOK and NRZ. Typical speed is 1 gig or 2.5 gig. There are two world standards. For the fifth generation, it is going to happen 2020s. It was EPON and GPON, but have a lot of new improvement. It also point-to-multipoint system. Modulation format is also the OOK, NRZ, but the big difference is adopt a new DSP algorithm, which speed is 10 gig and 50 gig, which is to be defined. Now, I'd like to share my thinking about the CPN and standardization. For me, the nature of CPN, I think the first nature of CPN is a private network owned by the customers. It is an open and diversity market with scopes, service demands, media quantity, and the form of terminals are totally different. Also, this is a very diversity of technologies were coexisting for a long time. So the standardization of CPN is very low progress and also have a low necessities. Only the Wi-Fi has been well defined by IEEE and the WFA. So my suggestion is Wi-Fi generations will be defined as the first priority. The other we can postpone to the future. The generations on Wi-Fi access, which is well defined by the IEEE. It was also the new spectrum and the systems, one generation every 5 years, 10 times speed for the first generation to the fourth generation, 40% more speed for the fifth. For the first generation, it was happening in 1997, which is based on 802.11 standards. Working wavelength is 2.4 gigahertz. Typical speed is 2 meg, which is a direct sequence spread spectrum. This is the world standard. For the second generation, it was happening in 1999 to the 2003, which is based 802.11 BAG. Wavelength is 2.4 gigahertz. Typical speed is 11 and 54 megabit. The modulation is OFDM and 64 QAM. This is the world standard. Third generation, it was happened 2009, based on 802.11n. Working wavelength is 2.4 gigahertz and 5 gigahertz. Typical speed is 600 megabit, based on MIMO and 64 QAM. It was the world standards. For the fourth generation, it was happened 2013, based on 802.11 11AC. Working wavelength is 5 gigahertz, based on MU MIMO, 256 QAM. It was a world standard. For the 5th generation, which happened 2019, based on 802.11ax, working wavelength is 2.4 gigahertz, 5 gigahertz, 6 gigahertz. Typical speed is 9.6 gigabit, based on OFDMA and 1024 QAM. It was also the world standard. So this is all my thinking about the fiber 5G to share with you. Thank you very much.
Thank you, Wei. And now it's time, we're still going to stay with video. We're now going to move to Italy in Europe. And it's my pleasure to invite the chairman of the Industry Specification Group for F5G from ETSI. Please welcome Luca Pesando.
Good afternoon. I am Luca Pesando, working for Team Telecom Italia, and I'm here as the chairman of the ISG F5G in ETSI, which is the focus of my presentation, and I will tell you about right away. So in the first slide, you have information about the group itself that was created back in December 2019 in ETSI, and had its first meeting in ETSI's headquarters in February. Since then, and at that moment, the work plan was defined, the meeting agenda was defined as well, and we are next to having our second face-to-face meeting, which will be an online meeting, unfortunately, and not really face-to-face, next week. The group has grown from 10 founding members up to more than 30 now, with top layer representatives from the different industry segments. And there are now very good chances to do a good job. But before telling you more about the group, next slide is showing you some information about why this group was formed, what are the intentions, what are the aims. So essentially, the huge demand for fiber we are observing is requiring some answers. And fiber is becoming essential in our technology, in our communication technology, because it's not enough anymore with new services being offered. It's not enough anymore to stay with fiber to the home or fiber to the building or fiber to the factory. We need to penetrate inside to go more into small areas, to go to each individual machine in the factory, to go to each desk in the office. It means moving from fiber to X to fiber to anything. And this is also something very much required for exploiting in the right way what the 5th generation of mobile has delivered. And let me go to next slide and show you some comparison between this word, mobile technology world, and the fixed networks world. Well, the mobile world is governed by 3 fundamental institutions with a very well-defined process that is working terribly well. And that's 3GPP, defining technology, defining all the details in the standards. ITU as well does standards and defines with its standards the assignment of the different frequencies to different services. That's fundamental and enormously important also from the point of view of regulation. And GSMA, the third organization in the picture, is also acting at that level and also providing input to both ITU and 3GPP, setting the market perspective rules for the mobile. And this works perfectly. We have the 5 generations there. 3GPP has been active from the third on and very successfully. On the fixed services side, we don't have the same efficient process. We have a scattered amount of efforts around different organizations that define bits of the technology that overall is needed to deliver services. This creates less efficiency and not a very good time-wise process, not timely deliveries. What can we do to improve that? That picture that is summarized in next slide, where the mobile is referenced because it works very well. It has now delivered 5 generations, ranging from analog to the 5th generation that is almost services to anything in the world with IoT, where 3GPP is a leader in delivering technology, and where there is good collaboration and stepwise increase between one generation and the other. While we have something poorer, I would say, on the fixed side, because there are, well, no generations defined, that wouldn't be a problem, if not that this corresponds to a slower adaptation and to a less precise adaptation of technology timeline. And there is an evolution, of course. There has been a huge evolution in time, but this is done a bit chaotically, and there are many SDOs that not always collaborate in the right way, and they don't have the same timeline. They are not tuned. So what we would like to see at the end is, in next slide, is something that allows to have a match in the progress on the mobile side with the mobile generations, and on the fixed side with some, let's say, fixed network generations. And that's why we call the group F5G. We have to define this 5th generation. We are able to identify what are the essential characteristics of the past generations anyway, that have not been reached in the same efficient way as the mobile generations, but they are there. And we moved from voice over POTS and trunking at very low bit rates to hundreds of bit rates for trunking nowadays, of hundreds of gigs for the bit rates, and ultra high definition TV delivered to the end users. But now we have IoT emerging, we have a lot of new aspects to cover, and we need another step ahead. That's the aim of F5G, ISG F5G. Want to understand, define the 5th generation need, performing an analysis of the evolution in the past, performing a clear analysis of what the technology is now and what are the gaps to be filled to have something compliant with the needs. Therefore, this means defining new technologies and understanding where these new technologies have to be developed. Because some of them are already in progress, maybe. Some are totally lacking. And we have a spread know-how in many other bodies. We will not be able to work alone. We don't have any chance to take over what big groups and well-affirmed groups like BBF, like IEEE, like ITU, like ITF are doing now. We need to collaborate with them and fill the gaps that they will not be able to fill. What for? Well, to get to what you see in this slide, that is taking video as a central service, because it's central indeed to telemedicine, to industrial applications, ranging from what it was before, standard definition, now 4K, 8K, virtual reality. And this implies an evolution in the number of fibers per square kilometer available. The final point of termination of the fiber connectivity, ranging from what it was the building to the room, to each machine, to each light post in the city or each water pump. And this means evolving the technology, evolving from gigabit to terabit in the bit rate. Factors of 10, factors of 100, multiplying the performances of the network today. Again, it is fundamental that this is done in a big ecosystem with big players in it, very important organizations like IEEE, like ITU, with long tradition and huge know-how, but they need to be able to talk to each other, as well to the mobile area, of course, which is fundamentally awaiting for some results delivered by the fixed area networks. So, moving to next slide, we have a precise time plan now defined in F5G. We have 5 work items that imply for some of them cycling with releases as well, that will be addressing increasing characteristics of the services and of the technology supporting them. And we have several deliverables, therefore, in plan and in progress. We are confident that what is our aim, and has been stated in the previous part of my presentation, is reachable, and that we need to do that not just alone, but in collaboration. Collaboration with all the stakeholders that are represented at the bottom of next slide. And this will create a virtuous circle in which, from a vision, from a plan, from a new technology definition, we move to a standard, we move to delivery and to services to the final user, enhancing the market. And the market is huge. There are $1 trillion around it. That means 50 million kilometers of fiber to be deployed. That means 50 million connections to be deployed. That's a lot. And it's there for us to make it happen. We are confident that we make it together with all the other relevant partners. Thank you very much.
Thank you, Luca. We're now going to go from Italy back to Beijing. It's my great pleasure to introduce the next speaker, who has the coolest name ever. Ali is the Deputy Secretary General of the China Broadband Development Alliance. Please move on to video. And Ali, please.
尊敬的韦总、汪总。
Distinguished guests and friends, online and offline. Good afternoon. I'm Deputy Secretary General of China Broadband Development Alliance and Head of Institute of Technology and Standard Research, Chinese Academy of Information and Communication Technology. I'm very glad to be here today to share with you about my ideas on the exploration and practices of F5G in China. We know that there are 5 generations in the mobile communication, and the same applies to the fixed network. The first and the second generation were featured by the copper lines, and in the first generation, it was mainly aimed to address the 10 meg and lower narrowband voice communication problem, and in the second generation, the focus was about the bandwidth access below 10 Mbps, and the third generation was the transition between copper line and FTTH. And we adopted FTTB and DSL. The fourth generation was fiber to the home. Also, China was taking the lead in FTTH through the EPON or GPON technology to address the bandwidth access at around 200 Mbps. And for the fifth generation of fixed network, we are aiming to use new GPON technology to provide the capacity of 300 and 500 Gbps. We are also talking about F6G in the same time. And we want to achieve even 50 GPON in the future to ensure 1 giga speed for all household users. The F5G is different from the technologies in the previous 4 generations, because for the 4th generation, it's mainly about household applications, while in the 5th generation, it is also 2B oriented. There are many 2B scenarios and applications emerging. So that means that the features and user experience at the fixed network will be quite different. ETSI also defined the basic technical requirements of F5G, including on bandwidth, the bandwidth provisioning at a fine granularity, and also the requirements by industry internet to provide millisecond level latency. There are actually 5 driving factors behind China's FTTH development. The first is the well-developed broadband network in China. And I have some statistics to share with you. Now there are around 456 million household broadband users, #1 in the world. And the penetration rate of fixed FBB has reached 90%. And of these, FTT users takes up 90%, reaching 93%. So for China as a developing country, to achieve FTTH throughout the metro is quite challenging. And China's carriers have done a lot of work to achieve that. And the second driving factor is that the access rate now has already passed 100 Mbps. And according to the statistics of our alliance, by Q1 this year, the access rate in China has already past 160 Mbps. And the next, we are targeting 300 to 500 Mbps, and even 1 giga for some users. In F5G, according to the latest statistics, the number of giga users have already reached 1.97 million households, almost 2 million household users. Of course, that is still a meager number compared with 456 million. We still hope that there could be a quick expansion in the future in the next few years. And the third driving factor of China's FTTH development is the industry policies. In 2013, China released the Broadband China strategy, which is a very good driving force and facilitator. In recent years, the country has already released a series of policies to support the development of infrastructure, telecommunication infrastructure. And there are also some initiatives about the new infrastructure projects. The government strategy is to using the development of one dense industry to drive out development of multiple industries. The new infrastructure projects include telecommunication sector. When we talk about telecommunication infrastructure, 5G, of course, is taking the lead, but we should not forget fiber broadband as well, the fixed broadband, which is also a very important part. It is unparalleled with 5G, and it is strategic. The MIT also mentioned, since the fixed network is of a strategic importance, so it has to be deployed in advance. Before there is any needs or requirements coming out, the infrastructure for fixed network has to be ready. And the Ministry of Information and in the Industry and Information Technology is also mentioning about higher speed and improvement of FG as well as F5G. In the previous 4 generations of a fixed network, it is mainly about meeting the requirements of household users. But in the 5th generation, fixed network also needed to meet the requirements of enterprises and industries. That means there are more challenges and demanding requirements. For instance, 100 megabit above uplink connections, speed, as well as millisecond level latency and 99.99% availability. That is unprecedented in the previous time. So F5G has to meet both the 2H requirements and 2B requirements and the factory requirements. The development of F5G technologies also enable the quick deployment of fixed network, be it 10G-PON or G-PON technology. The standardization work was already finished 5 years ago. The relevant technologies are already mature. The system level line card, the MIG chipsets, optical modules are all ready. Now, we not only want to bring gigaband to the household, but also to the room and to devices to meet gigabit level experience at device level. And to achieve that, we still need some new technologies, such as Wi-Fi 6. The current Wi-Fi 6 technology still needs to be improved to achieve that. Another driving factor is market competition. There is already fair competition in the fiber era, unlike the copper era, where there is some monopolization. We know that Starting from Q3 last year, China Mobile, the traditional mobile network carrier, has already become a heavyweight player in the fixed network. And there is already fair competition going on. This can drive the development of the technology to meet people's need. The gigabit services are already put into commercial use in 29 provinces. China Mobile and China Telecom have already released the commercial tariffs in 25 provinces. So we are already seeing that momentum. So you may ask whether the mobile 5G will affect the development of fiber 5G. Actually, we see that in the past, the mobile 4G and the fixed or the fiber 4G are developing unparalleled. There is no such thing as replacement or competition. Mobile network is flexible, while the fixed network is reliable and stable and is not so sensitive to the mask of signals and the blocks like buildings. So mobile and fixed networks can be applied to different scenarios. In recent years, domestic or Chinese operated carriers and foreign carriers are bundling mobile and fixed services together with video services for market competition. I think in the 5G era, there can also be such bundling. You know that the fixed network has lower churn rate, so it can help retain mobile users. That's why we're emphasizing using the fixed services to retain mobile users, and while at the same time using the mobile users' large user base to support the development of fixed network. F5G's development will bring some changes to the network's architecture. Now we're talking about 10 GPON, and we're looking at 50 GPON. To provide cost-effective 50 GPON, we still have a long way to go. Besides, we have to ensure smooth evolution to reduce the cost. Now, to achieve this lower cost smooth evolution, we have to be able to reuse the ODN devices we adopted in the F4G era. If we can do that, the network deployment cost can be significantly reduced. That's different from the mobile network. We know that to develop mobile 5G, basically all the equipment have to be replaced compared to the 4G. We are going to introduce some new technologies in the architecture, like network slicing, edge computing, and some STB-like functions. And the introduction of MEC technology to lower the latency in the industrial network. Access technology and household networking technologies are going forward hand in hand. We have to address some bottlenecks along the way, and some new technologies have to be used. During the F5G era, a lot of work is going on, such as standardization. For the telecommunication industry standards always goes first. For fixed broadband, there is also a lot of standardization work to be done. We noticed that ETSI has already been working on the technical structure standards for F5G. We hope there is not only system and architecture level standardization, but also acceleration of deployment of 10G-PON network. Not long ago, some operators already start invite for bidding on their 10G-PON network deployment project. Network and applications are mutually reinforcing. Some services and application innovations are already mature for commercial use, and some are still to be explored. This year, we plan to carry out some innovation contests and some pilot programs to further drive up the innovation. F5G may bring new challenges on optical fibers, on the chipsets and components, and even technologies connecting the household. And there needs some synergy as well, and we are working to push that. And that's all from my part. Thank you.
Thank you, Ali. It surprised me, it might surprise you, to learn that there are 80,000 people watching this event at the moment online. 80,000 people for a technology event is good. And by the way, the F5G program welcomes new additions. So if you're from a carrier, another vendor, another stakeholder, and you want to get involved, you'll be welcome to join the organization. It's time for our final speaker. We're going to go now from Beijing back to the Mediterranean, to Portugal, to Mr. Luis Alvarito, who is the CTO from Altis in Portugal. Please, the video for Luis. Thank you.
Okay, good morning, everybody. On behalf of Altis Portugal, I would like, first of all, to thank Huawei for this invitation to be present in this Global Analyst Summit. We are living in challenging times due to the pandemic situation created by the coronavirus crisis that has forced most of us to be in social confinement and working from home. However, as someone said before, crisis moments create opportunities. And so far, we have been able to overcome the physical distance through the digital proximity. That has been made possible by the extensive usage of telecommunication networks, especially the fixed networks, that allow telcos to keep their business, their services, and business of their customers to run close to normal. Portugal is a country with a high penetration of fiber, very good broadband facilities, and significant optical connectivity infrastructures. In the following slides, I will try to share that with you. As the leading operator in Portugal, we have a very interesting perspective of the evolution, and we have a vision that the evolution and future of communications will be based in three major concepts. I am speaking about digitalization, convergence, and connectivity. We believe in a fully digital world, driven by virtualization and cloud-native platforms, highly supported on global and converged networks and services, where everything and everyone will be always and seamlessly connected to contents and platforms, independently of their location and access media. But also, we have a clear understanding that network quality and innovation drives business performance, and that the technology evolution supports business growth and economic development. Let me now take the opportunity to share with you all the basics of the strategy that we have around fiber. Altis Portugal has a long-term strategy based on 5 major strategic pillars. I'm speaking about innovation, investment, quality of service, proximity, and social responsibility. We decided 13 years ago, back in 2007, to start a journey with the objective of covering 100% of the country with fiber. Our goal for 2020 is to achieve a total of 5.5 million homes covered. By achieving this objective, we will be able to promote FTTH and broadband for all independently of its geographical location. Today, we already account for 85 to 90% of coverage, more than 5.1 million homes passed, and our mission statement reflects clearly our ambition. We want to be the social economic driver of the country, and fiber is seen as not the only way to enable new services and innovation, but also a way to promote social inclusion, to promote country cohesion, to promote investment, to promote employment, and lastly, to fight small communities abandoned. Looking now for the European situation, it is clear that the growth and coverage and trend of adoption of FTTH continues to be a reality. Fiber is by far the fastest growing and adopted technology. And this will enable the construction of the digital connected society that every one of us is aiming for. Strong work and strong effort has been made by all member states, although with different realities, of course. This situation, boosted by strong public and private investments that are making possible to accelerate the goal of a full fiber connected Europe. Although some of the big countries in Europe are still lagging behind a little bit, the trend is clearly very positive. Looking at the EU 39, we already reached more than 172 million homes passed and more than 70 million subscribers. So looking at the EU 39, we already reached more than 172 million FTTH homes passed and more than 70 million subscribers, with a very positive trend over the last 8 years. However, there is still a significant gap to cover, once large countries like the United Kingdom, Germany, and Turkey have still relatively low penetration rates. However, the latest information available are promising, having in mind that the plans and potential growth for those countries, alongside with relevant growth in other big countries like France and Italy, are already the good news. But the story of FTTH in Europe is not only made of large countries and big cities. We have to look at the situation of rural communities. Altice Portugal, it's a clear example of that. Once in our strategy, we define FTTH for all as a way to guarantee small communities development and a way to avoid countryside abandon. We do not want to see in our country digital excluded communities, that's for sure. This strategy is embraced by public policies and followed also by other players. And it's making possible to see Portugal leading the FTTH deployments in small and rural communities, as you see in this chart. It is a common understanding that communications played a significant role on keeping the organizations and the economy working almost normal during the actual coronavirus crisis. That was possible due to the high penetration and reliable broadband communications through fixed connectivity. In Portugal, and normally and globally in many other countries, fixed IP traffic grew 80 to 85%. IPTV services observed increases above 50%. Interactive services and video on demand were also stressed. And even the social networks took the decision of downgrading video quality due to the large increase of traffic. The values that I show in this slide, 100 meg in the fixed network, 35 meg on the mobile network, were collected from speed test information provided by this company and available to everyone. But, as I said before, most of the network stress was felt in the fixed networks. And, as you can see, we were well prepared for that. Over the last years, the European Commission has defined ambitious targets for the development of better communications and broadband connectivity infrastructures, and of course, more competitive market conditions in Europe. Starting in 2010 with the Digital Agenda for Europe 2020, followed by the establishment in 2016 of the strategy and objectives for the connectivity for a competitive digital single market towards an European gigabit society, to be achieved by 2025 in fixed and mobile networks, such as gigabit connectivity for all main socioeconomic drivers, uninterrupted 5G wireless broadband coverage, and access to connectivity of at least 100 megabits per second for all, of course, upgraded to 1 gigabits per second. More recently, under the EU Connecting Europe Facility funding for 2021-2027, we see an enlargement of the scope and focus of the connectivity infrastructures to enable the digital transformation of the society and economies. We have no doubt that all fiber-based networks are key for the achievement of all these objectives established for Europe, and that mobile backhaul, for instance, based on fiber, will also be key for the success and the future of mobile networks such as 5G. But we are also conscious that there is still a significant way to go, namely, to continue to increase fiber penetration and adoption, to fill the fiber pipe with new and innovative services, to move fiber implementations to low dense and rural areas, and last but not least, to subsidize not only the demand, but also the offer. After a journey of 13 years of fiber deployment, we are today more aware than ever about most of the success factors involved in the way forward towards fiber to everywhere and fiber to everything. Just to highlight a few and share that with you, I would like to pinpoint some of the major ones. First of all, the necessary strategic alignment between business objectives and network deployments. In fact, we do fiber, all of us, we are doing fiber, because we have a consistent business transformation process and not because of anything else. A service innovation and a customer adoption strategy. Fiber development must be aligned with service portfolio transformation that drives customer adoption and, of course, new services. And last but not least, a network transformation and an innovation program aligned with the legacy networks phase-out program in order to avoid the traditional networks over networks dilemma. In fact, fiber deployments has to run side by side with the legacy network transformation program, involving also innovation and transformation in processes and systems. But of course, we have to overcome some of the challenges that we have ahead. The need of new services and applications that could benefit the overall business case of fiber deployments. The need to move to low density areas, usually less appealing for new services and also with a higher costs of deployment. From our experience, this is where a close relationship with all stakeholders, like application developers, business partners, municipalities, condominiums, etc., play, of course, a very key role. We aim that F5G is able to develop a clear evolution path for a new generation of fixed networks, involving new use cases, new business scenarios, and new applications. We also expect that the standardization work to be done will integrate an holistic vision of all the work that is being done by several organizations, addressing all the technical standardization domains and adopting an enlarged scope that can cover the aspects of architecture, services, quality, security, privacy, etc. This vision and expectations were the main reasons that led Altice Portugal to become one of the founding members of this F5G initiative. There are, as I said before, still several challenges ahead, but we will not abandon our vision of a new framework that will support new services and fiber to everything and everywhere, with, of course, wider benefits for citizens, enterprises, communities, and nations. This is a process that has to involve a large group of stakeholders, as is shown in the slide. But of course, we understand that only this way we can build a better future and with no limits for our customers. We see standardization as the best way to leverage competition and enable a critical mass in the industry, and also the best way to achieve interoperable solutions at reasonable costs for the users. At Altice Portugal, we want to take part of this revolution, contributing to with our experience on running networks and providing services, and we hope that more players, especially telecom operators and industry partners, can join this important initiative. Let me finish by saying that we are in the edge of entering into the gigabit society under the trend of digitalization, convergence, and full fiber connectivity. And that Altice Portugal is very proud to be in the forefront of the actual strategic transformation towards very high capacity networks in Europe. Let's now work together to build a new world of full of possibilities for our customers. Thank you very much for your attention.
Thank you. Thank you, Luis. That's the end of our presentations for today. This is an ongoing discussion, an ongoing dialogue. We don't have time for Q&A today. For the media, for the journalists, for the analysts who are participating, you may have questions. Please, can we change the slide? If you send your questions to this email address, we will do two things. One, we will aim to answer your questions as quickly as possible. Secondly, at some point in the near future, we will publish the Q&A on a website and let you have all the answers. So apologies we don't have time for Q&A today, but you can still have your questions answered. And if you want them answered quickly, the sooner we get the questions, the sooner we can give you the answers. With that, I want to call the event to a close. Thank you to everybody in the room. Thank you to the speakers, both online and in the room. And thank you particularly to those people who've been watching online, the 80,000 people who joined us today. Please enjoy the rest of Huawei Analyst Summit 2020. There are more events to come, and I hope to see you all soon. Thank you very much.